Welcome everyone, welcome to my channel Physics Pro, and today we have another problem. A particle of mass m is fixed to one end of a light spring of force constant k. So there is a spring with a spring constant k and there is a mass. There is a mass of mass m and the length and unstretched length L. The unstretched length L, obviously it is about the spring, it is unstretched. Okay, the system is rotated about the other end. So the system is rotated with some angular velocity omega in gravity free space. In gravity free space, that is g equal to 0. Okay, the increase in length of the spring will be okay. The spring will increase or not. At first, we have to understand the idea that if the spring will rotate or not. Okay, when something rotates, there is a rotational thing. The idea, if there is if there is a body and it is rotating about some axis, so what will happen? There will be two forces. Okay, one force will act like this. This is called centrifugal force. Centrifugal. Okay, centrifugal force, and there is another force. We say it is outward force, and this is centripetal. Okay, centripetal. So there are two types of force. One is centrifugal and another is centripetal. So if the body is tied with a rigid wire, then there will be no change of this radius or this orbit or anything. But if it is spring, then the spring will expand due to the centripetal force. Okay, so let's say that the spring is increased by some amount x. Okay, now we will discuss about the forces. So what are the forces on the body? So the body feels that there is a force here, and this force is balanced by some spring force, the restoring one. Okay, clear? Let's say this is Fc. Okay, centripetal, and that's the spring force Fs. Okay. Now, do you know the Fc? Fc equals to m omega square and r. And what about Fs? Fs, the spring force, is minus of kx. Okay, so this is Fs equals to minus of kx. Now, what about r? R is the length, this length. Okay, so r is the total length of the body when the body reached at the equilibrium. So when the body will reach at equilibrium, so at equilibrium, what will happen? These Fc and Fs will have the same value. Fc, we are taking mod because we are not taking the directions, but they are the same value. If it is, then we can say that okay, now the forces balances the system. That is the equilibrium situation. So we are writing that Fc is m omega square and r, and this is the mod. So this is kx. Okay, that's good. So what is r? So r equals to, look, L plus x. R equals to L plus x, and we are putting it here, or m omega square and L plus x equals to kx. So now we have to calculate the x. So m omega square L plus m omega square x equals to kx. Okay, and we are taking x, this term and this term same side, and taking x outside. So we are getting k minus m omega square, which is equals to m omega square and L, or x equals to m omega square L by k minus m omega square. So we have this answer, and I think the answer 2, that is the correct answer for this problem.